In this session, we're going to see how to perform something called synthetic division, which is a shorthand way to do long division, but it can only be used in certain cases. And for our first exercise, we're asked to find the quotient and the remainder of 3x cubed minus 12x squared minus 9x plus 1 divided by x minus 5 using synthetic division. The first thing I want to point out is that to use synthetic division, the divisor has to be in the form x minus c. In other words, it needs to be linear, and the lead coefficient needs to be 1. In that case, we need to know what c is. Now let's analyze this just a touch. If x minus 5 is supposed to be x minus c, then it must follow that 5 is equal to c. So what we do is we take that number, in this case 5, and we put it in what I like to call a penalty box. And then we use the coefficients of the dividend, and they've got to be written in descending order according to the exponent for each term. Okay, so here we have exponents of 3, 2, 1, and then the constant. And finally, we need to make sure that we aren't missing any exponents. That is, if this starts with 3, then we must have a 2 and a 1 and then a constant. And if we don't, we'll see how to deal with that. We're going to write these coefficients in order: 3, negative 12, negative 9, and 1. And if you want to see where this process comes from, there's another video about that, so you can look at that if you like. But I'm going to draw this kind of boxy looking thing, and here's the process. Bring down the 3, that first coefficient you wrote down, and then this whole process is multiply and add. 5 times 3 is 15, and then negative 12 plus 15 is 3. Do it again. Multiply and add. 5 times 3 is 15, and then negative 9 plus 15 is 6. Multiply and add. 5 times 6 is 30. 1 plus 30 is 31. And there it is. But we have to know how to interpret what we have. So what we originally started with was a third degree polynomial, right? The 3 was attached to an x cubed term. The negative 12 was attached to an x squared term. The negative 9 was attached to an x. And the 1 was our constant. We divided an x cubed, essentially, by an x. That x cubed divided by x is going to become x squared. The rest of the exponents will follow suit, and so 3 corresponds to x squared, the next 3 corresponds to x, 6 is our constant, and then 31, we were dividing, is our remainder. In other words, what we just found is that 3x cubed minus 12x squared minus 9x plus 1 divided by x minus 5 is equal to 3x squared plus 3x plus 6. That would be the quotient, and with a remainder of 31. So the quotient, 3x squared plus 3x plus 6, and the remainder, 31. Let me label that first one as the quotient, the remainder, 31. And that's what we were asked in this exercise. Next, here we're asked to divide using synthetic division. We've got 2x cubed plus 3x squared minus 5x minus 2. I'm going to check a couple of things first. Number 1, the exponents are in descending order, 3, 2, 1, and then a constant. And we also have all exponents present and accounted for. Second thing I want to check, the divisor, x plus 1/2, is in the form x minus c. What up with the plus? Well, in this case, it's x minus negative 1/2. In other words, whatever number you've got, x minus 1/2, x plus 5, whatever, change the sign. That's the number we're going to put in the penalty box. So for x plus 1/2, I use negative 1/2. Coefficients in descending order from the terms, 2, 3, negative 5, negative 2. And that first 2 comes straight down because we're dividing by something that has a lead coefficient of 1. That first number will never change. And now that's right, multiply and add. Multiply and add. So negative 1/2 times 2 is, negative 1. And add 3 minus 1 is 2. Do it again. Multiply negative 1/2 times 2, still negative 1. And add negative 5 and negative 1, add up to negative 6. Multiply negative 1/2 times negative 6. It's going to be a positive 3. And add negative 2 plus 3 is 1. We weren't asked for the quotient and remainder this time. We were asked to divide. So the answer is going to be that 2x cubed plus 3x minus 5x minus 2 divided by x plus 1/2 is equal to some sort of polynomial, I'm sure. Well, let's look. At first we had the first term 2x cubed. So that first term was associated with x cubed. We made sure everything was in order. So the next one would have been x squared. The next one would have been x. And then finally the constant. When we divide x cubed by x, we drop a degree. And so the first part of the answer, that 2 is associated with an x squared. The next 2 with x. The next one, negative 6, is the constant. And then finally 1 is going to be the remainder. 2x squared plus 2x minus 6 plus 1 over x plus 1/2, right? And this form here is the quotient plus the remainder over divisor, kind of like a mixed number. Since we were asked to divide, we need to give the answer in this form. If we were asked for the quotient and remainder, we'd answer that. Next, we're asked to find the quotient and remainder using synthetic division, and the expression is negative 6x to the 4th plus 25x cubed minus 18x minus 13 divided by x minus 3/2. Well, I see that the divisor is of the form x minus c, and in this case that c is going to be that 3/2, and I'm looking at exponents and I see that they are in descending order. They go from big to small. We've got negative 6x to the 4th. We have an x cubed. We have an x squared and then a constant, but then I see we're missing something. So we're going to have to fill in a 0 in our synthetic division. 3/2 is going to go into the penalty box. And then we've got negative 6, 25. Well, let's back up. And then we've got negative 6, and that's associated with x to the 4th. And 25, that's associated with x cubed. Notice we don't have an x squared term, so I'm going to use a 0 as a placeholder there. For our x term, we have the number negative 18, and finally our constant is negative 13. If we consider what kind of answer we're going to get, we know the first term in the answer is going to be the result of essentially dividing x to the 4th by x. And so it's going to be x cubed. Then they're going to decrease one by one, x squared, x constant, and then finally the last number we get is going to be our remainder. And remember, we bring the first coefficient down, in this case negative 6, and then we multiply and add. So negative 3/2 times negative 6 is negative 9. Add that to the 25 that's there, and I have 16. Oops, and then multiply again. 3/2 of 16 is 24. Add that to the 0, I get 24. That's always fun. 3/2 times 24 is going to be 36. Add that to negative 18. we get 18. And finally, 3 halves times 18 is 27. Add that to negative 13, we get 14. Since we were asked for the quotient and remainder, our answer will look like quotient is negative 6x cubed plus 16x squared plus 24x plus 18, and remainder is going to be, is going to be 14. Since that's all we were asked for, this is a sufficient answer. One thing I'd like to point out is, you notice in our answer, we have an x cubed term, we have an x squared term, we have a linear term. Under what circumstance would we have a term that skips an exponent in the answer? Well, the answer to that is if the result of adding after multiplying in the synthetic division turns out to be a 0, then that coefficient would be 0 and that term wouldn't show up. But here you go. Our next consideration is, can synthetic division be used for something like x cubed plus 3x squared plus 4x plus 3 divided by 3x plus 6? Our first thought is no, this divisor is not in the form x minus c. In fact, it's of the form, if you like, ax plus b. Is there anything I can do to force this square peg into a round hole? Turns out there is. If I can multiply the numerator and denominator by an appropriate number so that the lead coefficient of the divisor becomes 1, we're good to go. What this essentially means is, since our divisor is 3x plus 6, if I divide numerator and denominator by 3, the denominator is going to have the right form. Another way to look at dividing is multiplying by 1/3. Notice we're multiplying numerator and denominator by 1/3, ultimately multiplying by 1. This affects the way the problem looks. It also affects the remainder we're going to get. We'll see that in just a minute. When we distribute in the numerator here, we're going to end up with 1/3 x cubed plus x squared plus 4/3 x plus 1. Distributing in the denominator gives us x plus 2, and now all of a sudden we have a divisor of the form x minus c. In this case, that's c being negative 2. I'll go ahead and perform the division and then we'll talk about what we're looking at. Okay, so I've done the division with all the colors that I've been using, and you might want to double check that this is all correct, but I assure you it is. We divided a third-degree polynomial by a first-degree polynomial, and so the answer is going to be a second-degree polynomial. We have a linear term, we have a constant term, and we have a remainder. Now, this is where things get just a little bit tricky. The quotient is no big deal. It's 1/3 x squared plus 1/3 x plus 2/3. However, what we have for a remainder is negative 1/3. That would be the case if we were really dividing by x plus 2. But if we look back at the original problem, we were supposed to have been dividing by 3x plus 6. So if I wanted to express this as quotient plus remainder over divisor, I'd have to make sure the divisor turns out to be okay. In this case, we'd end up with 1/3 x cubed plus 1/3 x plus 2/3 minus 1/3. When we did the synthetic division, that was over x plus 2. But check it out. We'll just focus on this remainder part. 1/3 over x plus 2 is the same thing as 1/3 times 1 over x plus 2, giving us 1 over 3x plus 6. And so the actual remainder, well, these were all negative, weren't they? is -1. Oh, wait a minute. Did you catch it? I said the first term was 1/3 x cubed. What was I thinking? Supposed to be x squared. If you caught that, good for you. If you didn't, pay more attention. So the short answer to can synthetic division be used in the case that the divisor is 3x plus 6, the short answer is yes. But then the fuller answer is, but you got to fix the remainder when you're done. And I don't know that this is optimal. Another question, could synthetic division be used in the case where your divisor is like x squared plus 3? The answer is no. There's no way to fix this. Synthetic division has to be used with a divisor that is at most linear. So x minus c is optimal. Ax plus b could be fixed. The fact is, though, you probably don't want any part of this. You would just use long division.